Okay, in this problem, a light rail commuter train accelerates at a rate of 1.35 meters per second square. How long does it take to reach its top speed of 80 kilometers per hour starting from rest? Okay, let's do part A first. Now we have to convert this 80 kilometers per hour to meters per second. So that's 80. A kilometer is 1,000 meters, and 1 hour is 3,600 seconds. And so this works out too. So this is essentially 1,000 divided by 3.6. So that's 3,600. That's 1 over 3.6. So you just divide 80 by 3.6. And this gives us 22.2 meters per second. So how long does it take to reach the top speed? Okay, so we'll use this. Final velocity is initial velocity plus acceleration times time. So the time taken is that, and the final velocity is 22.2 meters per second. Initial velocity was 0. Acceleration was 1.35 meters per second squared. Okay, and this works out to 16.5 seconds. So in 16.5 seconds, the train has reached its final velocity. Okay, so now when the train applies, so it's going, now we'll say the train is moving at 22 meters per second, 2 meters per second, and now it wants to stop, so the acceleration is in the opposite direction. So now how long does it, the acceleration is, since it's in the opposite direction, it's negative 1.65 meters per second squared. And how long does it take? Now how long does it take to come to stop from top speed? So again, we'll use the same equation. We use V0 plus AT. T is V minus V0 divided by A. Now the final velocity, you want the train to come to stop, so that's 0. 0 minus 22.2 meters per second divided by negative 1.65 meters per second squared. And this works out too. This works out to 13.45 seconds. Now, this is a common theme, and let me point out, when you're accelerating, your acceleration is 1.35 meters per second square. And your deceleration, when you're braking, your deceleration is always greater than the initial acceleration. Because stopping, you want, more often than not, you want to stop faster. Okay, so it takes less time and less distance because the acceleration is greater. So stopping time is that, and acceleration time to get to the maximum speed is that. All right, and then so we have a part C, so let's add a page. So part C says, in emergencies, the train can decelerate more rapidly, coming to rest from 80 kilometers per hour in 8 seconds. So in an emergency, you see it takes much less than 13.4 seconds. It can stop in 8 seconds. So what is the emergency acceleration? So again, we'll use the same equation. V minus V0 is, again, this is 0, you're stopping, so 0 minus 22.2 meters per second divided by 8.3 seconds. So maybe 2.67 meters per second square. So the emergency acceleration is 2.67 meters per second square, and the normal deceleration was 1.67 meters per second square. Of course, you don't use that all the time because that's a jerky stop. Well, it's and people don't find that comfortable. So anyway, that's that.